Just out of curiosity, I was looking at the analysis of the bismuth that I'm buying for its purity. It's 99.9949 pure. And the most common impurity, I'm a little bit surprised, is apparently copper. I'm surprised by that because I actually tried to make an alloy of bismuth and copper at one time, and you have to heat it almost to the melting point of copper to get an evenly uniform alloy. I was researching what alloy I needed in order for the metal to have the same density as both a liquid and a solid, so that I could pour something very uniformly. And you needed a very high temperature. It was really not worth the effort. So I'm a little bit surprised copper is up there. You would think if you had any sort of alloy of bismuth and copper, the copper could easily settle out of it. Lead seems a little bit more believable. Zinc I find very difficult to believe too, for the same reason. I was actually a little bit concerned that, because I was also melting zinc, that I would cross-contaminate bismuth and zinc, but the zinc separated itself out. Well, it didn't contaminate the crucible in the first place, and it certainly didn't contaminate the bismuth because it wouldn't melt at the kind of temperature you're dealing with when you melt bismuth. But what's really interesting is the amount of silver in here. That's actually not a very insignificant amount in terms of value, by the way. So if I order 1,000 pounds of bismuth, and I have 1,000 pounds, and there is 0.0024 divided by 100%. That's how many pounds, and then multiply by 12 to get how many ounces. So out of the 1,000 pounds of bismuth that I ordered, there's potentially 1/4 of an ounce of silver, right? Think a couple silver dimes or a silver quarter mixed into all that bismuth, right? I don't know why, that just gets me excited. A little bit of a bonus, right? Although it probably does contaminate the bismuth to the point that it's making less impressive crystals, right? Who knows? Who knows? But it makes me wonder how we ever figured out that bismuth is radioactive, right? If it's so hard to get very pure bismuth in the first place, how do we know it's not detecting something else, right? And certainly, even if you could purify all this out, the other problem is that bismuth has a couple of isotopes that exist in nature, right? So how do we know it's not those isotopes that are giving off the radiation, right? I think 209 is the only one that supposedly has alpha decay, right? The other ones all decay beta, but then polonium also decays with alpha decay, right? So you could be measuring those alpha rays as well, right? Anyway, I'm a little bit surprised that there's so little with chlorine as well. You would imagine bismuth oxidizes a lot when you melt it. I would imagine some of that is bismuth chloride, right?